Hello student, in this class we'll see when a parallel plate capacitor is taken and once it is charged, what is the electrostatic potential energy is stored between the two plates of the parallel plate capacitor, and then what is energy density, that is electrostatic potential energy stored per unit volume of the capacitor is known as energy density of the electric field, that also we'll find out. And then we'll see once the capacitor is charged, in charging process some heat is dissipated in conducting wire. So what amount of heat is dissipated in the conducting wire? So let us see all these things. Now when we take a parallel plate capacitor, then its capacitance is given as epsilon naught A by D. Suppose the two plates are having area A and D separation, and then I can say the capacitance of this parallel plate capacitor is epsilon naught A by D, right? This is the capacitance. A is the area of the plate. Now once this capacitor is charged, means it is connected to a source of electrical energy. Suppose it is connected to a battery, then the capacitor within a short time, within fraction of second, the two plates of the capacitor is charged. How? The positive terminal of the battery attracts all the electron of this plate, right, left plate. So this plate develops positive charge, and since electrons are flowing in this wire, it goes to the second plate. The battery supplies these all electrons to the second plate, so this develops a negative charge. So let us take plus Q is positive charge and minus Q is the negative charge on the second plate. So I can say in this process of this process takes place for a very short time, and in steady state the charge Q is on the two plates of the capacitor. So I can find out what is the electrostatic potential energy stored between these two plates. Now how to find out electrostatic potential energy is stored? So what we will do, we will find out what is, we will forget this plate is not there, and we will find out what is electric field at a distance x from this plate. So I can say the electric field can be written as, if you take, this is a plane sheet of charge, I can write it is sigma by 2 epsilon naught, right? This will be the electric field intensity at all these points. Let us say this is E, right? Now once the negative plate is placed at this place, it will experience electrostatic force of attraction between these two plates. So I can say the force of attraction can be written as the force is Q times E. The Q is the magnitude of the charge, and then I can write Q square by 2 A epsilon naught, because sigma is Q by A, right? So this is the force of attraction. Now to make this capacitor, I will take the second plate to a distance D. So some work is done also, external work is done. What is this external work is done in separating the two plates? I can write force into displacement is D. So I can write Q square D by 2 A epsilon naught, and this can be written as Q square by 2 A epsilon naught divided by D. Now this value is nothing but capacitance of the parallel plate Q square by 2C. Now once you replace Q by CB, so I can write it is half CB square. This can be also written as half QB. All these are electrostatic. Now this is electrostatic potential energy stored between these two parallel plates. This is force of attraction acting between these two plates. So once the electrostatic potential energy is stored, I can find out what is energy density of this field. How to find out energy density? Energy density is written as, energy density can be written as small u, and this is capital U by per unit volume, so A into D. The volume of this space is A into D. So I can write the energy density is U. Now you place this value, I can write the energy stored was Q square D by 2 A epsilon naught. 2 epsilon Q square D by 2 epsilon naught is U, and AD comes, right? So I can write this value as Q square by 2 A square epsilon naught This d gets cancelled. I can cancel this. Q square by a square epsilon naught. Now this can be written as sigma square by 2 epsilon. Now sigma is nothing but sigma can be written as sigma by epsilon naught is electric field. So you can replace this value. I can write this as half epsilon naught E square is energy density, that is energy stored per unit volume of the capacitor. Right, so this is the force of attraction, this is the work done in separating the two plates by d distance. This is stored in the form of electrostatic potential energy, in the form of electric field inside this, between these two plates of the capacitor. I can find out what is energy density. If you divide it by volume of the space, that gives you energy stored in unit volume. And what is its value? Half epsilon naught E square. Now you will observe this energy density depends on electric field. More is the electric field, high is the energy, more is energy density of the field. Now in this process of charging, since the battery has taken Q charge from the positive plate and supplied to the negative plate, so battery is doing some work in this process. Now what amount of work is done by the battery? So I can find out work done by battery. Battery is nothing but charge type potential Q times B. Q is nothing but CV, so C times V square. Now energy stored is how much? In capacitor is half CV square. So what amount, since the charge is flowing in this conducting wire, so this charge gets kinetic energy, then it collides with other charges, other electron, it loses its electrical kinetic energy. So this kinetic energy is converted into heat energy, and the heat energy, what amount of heat energy is created or dissipated in this conducting wire can be found out how the total work done by battery CV square. Energy stored in this portion is half CV square. So energy which is dissipated in the form of heat in conducting wire, so heat energy I can write that is nothing but total energy stored minus energy stored, total energy work done by battery minus energy stored. So this can be written as half CV square. So this is the amount of heat developed in this conducting wire. Thank you. If you like this video, please subscribe the channel.